Hello, my name's John, and our group investigated how we could find specific pitches using various lengths of PVC pipe. So what we did was we ended up going to Home Depot and buying this pipe and making our own instrument from things that you would normally use in your house. So we arrived at this idea when we were thinking about other examples of handmade instruments. So the Blue Man Group are a group that are pretty famous for kind of what they're creating and for their creativity. So they have created something similar out of PVC pipe. So this is kind of what we tried to emulate, and what it ended up looking like was something like this. So obviously you can see our instrument over here is not nearly as complicated as this young man's here. He looks like he's having a lot of fun, but ours is the basic premise is the same, and he is also using some sort of spatula type object to hit his instrument. So we use PVC pipe that is 2 inches in diameter, and we were able to find an equation online through Belmont that helped us to predict what length our specific types or specific pipes should be to find the notes in the harmonic scale that we use. Our questions for after doing our research, our questions that we came up with were, can we accurately predict the pitch of pipes using our mathematical equation? And how do different paddles affect the timbre and amplitude of the sound of the pipes? So to investigate these questions, we created our instrument over here.
Hi, I'm Kyle. A lot of you already know that, and I'm here to talk about the physics and the science behind our project. So as you can see here, it's a bunch of PVC pipe tubes that we got cut at Home Depot using this formula to determine the length. So we got a bunch of notes in a pentatonic scale, which you'll learn more about later. And we got their frequencies and we plugged them in here to get the length of the tube in inches. So after doing that, we basically cut them all at Home Depot. There was a little bit of a problem though. The machine to cut these tubes was broken, so we had to cut them by hand. So there's a little bit of human error, but that's okay because it should be fine. So now we can go talk about this. These are open tubes. So both sides are open as you can see over here. And so what we're going to do is we're going to hit one end, and it's going to send sort of an oscillation of air pressure through it, and that's going to sort of reflect back as a rarefaction off the other end. And we talked about earlier in class that creates sort of a low pressure zone that reflects back along the tube instead of the air just bouncing off like a closed wall or something like that. And so that's going to be how the tube is going to act sort of like a resonator, and it's just sort of going to reflect back and forth as this tone is created. And you're going to hear that later in the video. It's not just like instantly done. It's just gonna linger for a little bit until the energy of the wave dies out. Okay, and so these are the notes that we tried to pick. These are the hertz of the actual notes, and so these are what we were aiming for. The formula that we used predicted the numbers that we would get. These are the numbers that we actually measured in Logger Pro. And so as you can see, we're a little bit off because one, there was some human error with the Home Depot stuff, and but for the most part we were pretty close. These notes, the higher notes, actually got kind of a little wanky, but that's okay. These in the middle, just to clarify, are the actual frequencies of these B flat 3, C4, D4, F4, and G4. Again, these are the lengths of the tube. This is what the formula would have predicted the length should be. And so as you can see, these first three, this is what our instrument actually measures. So 26.8 isn't that far. It's, not really exactly, but these two are pretty close. These two are pretty close. And then as you get to see here, we get further and further closer to like an inch off. Okay, so this is some of our data from the longest pipe. The frequency that we measured here was 238.10 hertz. And so you can see we just did a little close-up. We used Logger Pro basically to get the one period, and then we use that to calculate the frequency like we learned in class. It's just 1 over the period length, or the time, I guess, in seconds. And so this is our second one. This should be C. And so here we go. There's another zoomed in portion. We're just going to go through these pretty quickly. This one is supposed to be 263, or we measured 263 hertz. Okay, this one is the D note. This one we measured at 292.23 hertz. So we can get a nice little picture of the wave as it sort of peters out, you know, as it is resonating through the tube. Okay, this one's F. This is 342 hertz as we measured with our microphone. And this last one is supposed to be a G. Again, though, these two were a little off, and we measured this one at 376 hertz.
So what we have here is a pentatonic scale in the key of B flat. So what that means is 5 notes are taken out of the B flat scale and are played in order, like this. The reason why you choose these notes is because you can play them in any order and they should sound somewhat good. So on the pipes, we created some sounds that are similar but are off by a few hertz, so they might sound a little bit out of tune. This is due to human error, as referenced before. So here is our song.